Hello guys, my name is Diego Pacheco and this is another Java video. Today we're gonna be talking about agents. So agents are an interesting feature of the JVM that allow us to blend in two different jars into a single application. And there is a couple of use cases for agent. Mockito, for instance, the Mockito inline mocker is an agent, and the use case is you have, let's say, a class that's static and final. And how do you mock that? How do you test that? Well, with the Mockito inline mocker, you will change the bytecode and sort of be able to intercept before and after that method, and then we're gonna be able to do what we need for the testing. The other use case is observability. Often logging, centralized logging solutions or metric solutions or traces solutions, they often needs to instrument the application, and they can do that with agents. And I would say the third use case could be wherever you need to run before an application or given a specific moment into application. So you can consider them as sort of like aspects, but they are transparent because really they're not embedded in your jar. That happens on the runtime. So an agent basically can be from two kinds. There's two types of agents, right? So you can have either static agents or you can have dynamic agents. So for the static ones, you're gonna do the mixing when you run the Java application. And the dynamic ones, there is a API on the JVM where you can remotely match to a specific PID of a Java application, and you can do that dynamically. One Java application can have more than one agents. Okay, so I have two different POCs I want to show you guys. First with Spring Boot, and the second one just a plain Java app. So with agents, you can either do two things. One, you can just run any sort of a initialization code or background code you need to run, which is sort of a transparent for the application, or you can do some bytecode manipulation and you actually can change the code of a target application. There are some limits to do that, but there are some things you can do. So first, let's go with a Spring Boot POC, how we can do agents there, and then we go with a standard Java app. So let me open my idea here, and this is a Spring Boot 2 app. Spring Boot 2 nowadays is sort of a default way to do services or microservices in Java. There are other interesting stacks like Micronaut, for instance. There's the Vertex stack. There's Quarkus. So, but in Spring Boot. So let me open my pom.xml since this is a Maven app in Java. Here I have two folders, right? I have Spring Boot app and I have Java agent. So as you can see here, I have a module in Maven, my root pom.xml, and I'm saying I have two modules. I have the Java agent, I have the Spring Boot. And here I have a generic assembly plugin, which will need to make a fat jar with the dependencies. And I'm setting here so I can run the commands on the top level project to assemble it. So for the Spring Boot app, let's go to the pom there. And what we have here is the latest Spring Boot right now, which is 2.52. I'm setting the Spring Boot parent as my parent. This is Java 8, as you can see. And I have the classical dependencies as starter web, actuator, dependencies for test, and JUnit 5. And then here I have the boot Maven plugin, so I can run Spring Boot application with Maven. And I also have the assembly configuration here, so I can create a fat jar with dependencies. So now if we look at the code, there's really no big deal in sense of Spring here. I have a controller, is annotated as REST controller. You can see there is a slash index, and I'm just doing greetings from Spring Boot. And then I have an application, and the application I have the @Spring Boot annotation. I have the enable auto configuration component scan on this package. It's where I have my source code here. And then you can see here I'm just running the app. I also have a bin here. As the app gets available, I get the application context. I just print that Spring 2 is up and running. So we can run this app quickly here on IDEA, just you guys can see the app is fully working. So there we go. Here we see boot up and running. We can even do a CURL. Let me do here localhost 880, and we get greetings from Spring Boot. So the app is working. And then let's take a look on the agent code. So on the agent, in my POM, I also do not have dependencies. I have a config here for Surefire for testing in Maven, but doesn't matter. The thing that matters is assembly, and I have the manifest entry. That's something you need to change. So here you need to tell if you're gonna redefine heat transform classes. For this, I don't need to, so I'm passing false in both. And then you say what's your agent class and your pre-main class. So these are the two hooks. You can customize it. I will talk more in a moment. There is also possible, if you want, you can do this in src main resources meta-inf, and then you can create a manifest.mf. You can also pass it here. Okay? If you do it so here, you need to have an enter on the last line. So let's look the code of our agent, right? So this code is pretty simple and straightforward. So as you can see here, I do not implement any interfaces. And the trick here is in these two predefined signatures. So you can have a public static void pre-main, and this, as the name say, pre-main, you're gonna run before the main method in Java. And I receive the args of the agent, wherever you are passing through, and I receive instrumentation. So instrumentation is from Java lang instrumentation, and this can be used to modify the bytecode, right? In this case, we're not doing that. I'm just gonna use a UUID run the UUID to a string, so I get a unique ID. I'm gonna print this unique ID. And the reason I'm doing this is because I want to run multiple agents. And based on the ID, you're going to see that are multiple agents running. So I create a thread, a background thread, and I have a while true. So this code going to run forever. And what this code going to do is basically just print the agent ID saying that's running, going to sleep for 3 seconds, and I'm going to keep doing that forever. Right? So these I just can prove that you can have background applications running forever as your agent leave. So here I could be bootstrapping a server, cache, whatever I want to do in my agent. And the second one is the agent main. And this is for the dynamic agents. And the signature is the same. And I have agent args, wherever you pass, and instrumentation as well. Here, I'm just printing the UID. Actually, this one will never run because I'm doing the static version of agents. Okay? I think I have a build script where I'm just calling assembly to generate a fat jar. And for the Spring Boot app, I believe I also have a build, yes, to generate a fat jar. And I think somewhere here, I must have a run script. Let me see if it's in the top folder. Let's take a look. Okay, so here, okay, so let's go to the Spring Boot app. Let's build it. I'm just doing assembly to generate a fat jar. Okay, so let's run the build, building the application right now. Just wait for a moment. Okay, we build it. Yes, I have a run here. Let's see what my run does. Yes, that's the one I want to show guys. Okay, so let me open my agent here now. And I also want to build it. As you can see, just, using assembly to do a fat jar. So let's gonna build it. This is gonna be a bit faster. No Spring Boot here, so much faster. There we go. Okay, so if I go back to the Spring Boot app, basically there's three ways I can do this. There's always statical ways, by the way. So let me show the code and explain to you guys first. Okay, so these all work, but I'm just gonna use one. That's why the others are commented. So the first option is we can run before Maven. So what this bash script does is it gets the current dir with this dollar parentheses pwd, so get the current directory in bash, and you're gonna export the Maven opts, and then you wanna do minus java agent, and then you wanna do the current dir and then the path to the agent.jar, and you can do minus java agent again and again and again and define as many agents as you want. If you do this way in Maven OpenTS, this agent gonna run before Maven. This is useful if you have a custom Maven plugin or you need to run something before the build. That's your way to intercept the build and run code before the build. And this is very transparent, really cool. The second option is we're gonna use a Spring Boot capability with agents. In Spring Boot, it has this variable called spring boot.run.agents. And the syntax is a little bit different. You're gonna put the full path of the agent.jar, and then you're gonna do a comma for more agents, and then I'm putting the same agent twice. So this is gonna run after Maven, and we're gonna run when Spring Boot gonna boot, it's gonna run before booting. Okay, there's a third option, more like a vanilla Java app you can do in any Java app. So you can do Java minus Java agent, and then pass the full path of the agent, and then just do minus jar and pass your fat jar before Spring Boot. So these three ways work, different flavors, different trade-offs. Okay, so let me run, and you guys can see this in action. So there we go. So here in Spring Boot, it showed this attaching agents. And then we can see here we have one agent, we have two agents. And then you can see the pre-main code running. And we can see two different UIDs. So, and also we can see they're running. Then we can see the Spring Boot app booting. And here you're going to see they continue to show this because they're running. So easily we could do a CURL and hit that agent, right? So we can see here that it works and the agents continue running. So this is pretty powerful, pretty interesting for some capabilities you might have in your infrastructure using Java. So that is the first POC. So let me close this, and now let me show you the second one. So I'm gonna close this idea and I'm gonna open another one. So this is similar, but I'm not using Spring Boot now. And now I'm gonna do bytecode manipulation. So we're gonna change the JVM bytecode on the fly, right? Of course, there's some considerations here. If you have lots of hot reloads, this will be bad because every time you hot reload, the agent gonna run again, you know. So there are some things here that you need to keep in mind. So similar to the other one, I have a root.xml. I have two modules. One is called agent. The other one is called app. I also have assembly here for a fat jar. Let's start with the app. So the app really doesn't have any dependencies. It's a simple Java app. The only thing is in Maven, you can do this system path if you need to use a jar that is in your file system. That's done so I can access the tools jar from the JVM, JDK8. And I need that to do some of the transformations, all right? So this is a system dependency. And besides that, this is just a JUnit, but I'm not really using. So here I have assembly, so I can create a fat jar. And I also have exec, so we can run this as Maven. and I have a jar plugin, but I don't think I'm using this one. No, yes, I'm using this to generate the jar, and that's what we got for the pwn.xml. Now, let's take a look at the app. So this is like a dummy app. It's not really doing anything interesting. So there's this pseudocode emulating, like, oh, let's say, let's pretend we're gonna do something interesting. So there's a data process class, and it has a method called process data. And then there is an amount of data that you're going to process, but really what the code does is just log saying, oh, I successfully processed this amount of gigabytes, right? And then I have this agent loader where this can be used to deal with dynamic agents. So this guy is on the same app, so it self-loads, but it could be in another app as well. So here, what you need to do is I have the full path of my agent, and I have my agent fat jar with all dependencies, also the path, and also I have the full qualified name of my application class. All right. So in the JVM, we're gonna use this virtual machine that's from the tool jars that we saw on the Maven, and we're gonna do list, and with that we're gonna list all the JVMs running on the machine. Then we're gonna do some functional programming here. We're gonna stream, we're gonna filter, and we're gonna get one specific JVM, and the JVM we want is the one that the display name contains, or full qualified name of our main class from the application, and that's how we know what JVM we want. So here I'm just printing the name of the JVM, making sure I filter to get just that one. Then I get the first result, I do a get, and I get an ID. So then I have this JVM process opt, which is optional with string, where with that I can check if it's present, just to make sure that the JVM is up and running. Then I create a file, basically pointing to the jar of the agent, right? The fat jar of the agent. And then I'm gonna get the PID of that application, doing a get, and then I have the speed of the JVM showing the PID. And then I'm gonna do from the tools.jar virtual machine attach, and then I'm gonna pass the PID of JVM, and then I'm gonna do load agent on that JVM. So this is why this code generic is here on the application self-loading, but it doesn't need to be this way. Then I'm gonna put the full absolute path to that agent jar. I'm gonna do detach, and that's it. We dynamically load the agent. If we look the main application, what the main does, so this is the class we were looking for. So it just prints whatever arguments is receiving, and then it's checking, okay, if the argument is less than 0 or 0, then doing regular main, just thread sleep, say the app is running, process data, and ends, right? Otherwise, we're gonna load the agent, and then we're gonna do the regular main. And this is the code we saw to load the dynamic agent. Okay. Now let's take a look on the agent. So if I take a look on the agent, here in src resources meta-inf on the manifest.ms, like I was showing in the other video, you need to pass that you can head define and heat transform classes. So through both, here's my pre-main and here's my agent main. So this also can be done in Maven, as you see here on assembly plugin. You can do this manifest entries. All right. Now let's look the agent source code. So there's two classes. There's agent and transformer. I should call this Bumblebee or something, or Optimus Prime will be much better. So I have pre-main that's gonna run before main, and I have agent main. So in both cases, I'm gonna do transformation, and here I basically just log in. Oh, I'm running pre-main. I'm running agent main, and the data process. If you guys remember, that class, this one here, we want to instrument this code. Okay, so that's the class name. If we take a look on transform class, we receive a class name and an instrumentation. So this instrumentation is the same we receive from the hooks agent main pre-main from Java Lang instrumentation. So here we're gonna have a target class and a target class loader. So the first thing we're gonna do a class for name for the class name, which is gonna be this data process, this class right here. Okay. Then we also gonna get the class loader of that class, and then we're gonna try transform passing the class loader, and the instrumentation. If there's errors, I'm logging stack trace. Otherwise, what's going on? Let me go to transform. So I'm creating a transformer, which is this guy here. I'm adding a transformation, and I'm asking the instrumentation to heat transform this class. So let's take a look on the transformer, what the transformer does. So transformer is using Java Assist. So you can see here, right? But I'm implementing a class file transformer. And I need to override this method called transform. So I'm receiving the target class, the class loader, right? And the method that I want to change is called process data. So it's this method here. I want to instrument this class in this method. So we have when we override this transform, we have the class loader, the class name, the class being redefined, and we have this protection domain, and we have this class file in buffer. So we get this, which is our bytecode. So we do some regex here, we do some replacing, right? So because we want to get the name with like folders instead of dots. Then we're gonna check if they are the same. If they're not the same, we're gonna return, meaning we don't want to change any other class, just this one. So this is like a filter, this if here. Then we're gonna check if the class name is equals to the target one I want to do. And in this case, if you look here, the target class, it's gonna be this one here. Okay. And we also check if the loader is the same as the class loader. We are good. And then I'm logging. Okay, so this agent gonna transform this class. Then we get the pool of the class. Then we get this CLT class. And with that, we can get the declared methods of the class. And we want one specific method, which is this one, process data. And then with this method, look, we can add a local variable. So we're creating a local variable on this method called start time, and it's gonna be a long. And then this method, we are inserting this code. And here's the Java source code we want to inject. So I'm saying that start time, which is a long, I define it here, it's gonna be the value of system.currentTime millis. Then we have a string builder here, okay, and we are adding another variable called end time, and is a long as well. And then we have another one called op time, which is also long. Then we are appending on this block end time being the system current time millis, and op time being the end time minus the start time divided by 1000, so we can see this in seconds. Then we are appending printing, right, in Java, and say, oh, I hijacked this application, and here's how long it took to run. And then on this string builder, we are inserting after this block here, right? And then with this block, right, we are getting the CC, which is the method, right? And we are doing to bytecode. And this bytecode, as you saw here, is a byte array, which is pretty much the bytecode of the application. then we detach and we return the bytecode. So this bytecode was successfully modified by us, right? So we really change that method. And now I can run this and I can show you guys the result. So I think, let me see if I have, not sure if I have a run anywhere. Not sure if this one will do. Oh, I do here. So I have one that can be, I can show this running statically or dynamically. So if there is a parameter, it's gonna be static. If there, I don't remember if this there is not. And otherwise it's gonna be dynamically, but we can play around. So this run, let me see where I add it here. This run, where it is. Okay, it's on the root folder. Okay, let's play with this. So I'm gonna do here cat run. Okay, so let me see. Let me pass argument 1. Oh, it's dynamic. So it's running with a dynamic. Okay, so this is saying if this is not present, means we run here. Otherwise, if we have a value, we run here. So we are doing the dynamic load. And we can see here that we the args that we get with the the full qualified name of the agent. We can see that we are doing the dynamic load. Then we can see that we detect a JVM running. We attach to this VM to JVM with this speed. We do the bytecode transformation. We change the bytecode. We need the app. Then we run the 2 gigabytes, and it, as you can see here, it says it's running 0 seconds. So this code here, you see hijacked withdrawal operation. This is not in our source code. See here, we don't have that, right? That was the transformer doing that instrumentation right here on line 50. Okay, we can also do statically this way, and we got the same result. There we go. Okay, that's it. I hope you guys like it. See you next time. Take care. Cheers.